Hey guys, so today I'm going to be working on some problems from solving trig equations homework. Okay, so I had a question on question 5, how to do question 5, and I'm going to give you an example doing a similar problem. That would be problem number 7. It's pretty similar. Now remember that we have to take into consideration the limits for which we can use find our solutions are limited from 0 to 2 pi. So we cannot go above 2 pi or below 0. Okay, everything has to be within that range. So I'm going to show you how to do number 5 by giving you an example from a similar problem. That would be problem number 7. So I'm going to do problem number 7. So it's -4. Go back to my notebook, well, my papers. -4 tangent theta equals 4. Alright, so here we go. First thing that we have to do for these type of problems is to leave the tangent of whatever it is, or sine or cosine, by itself. So we have to get rid of this -4, and because this -4 is together with the tangent, there's no plus or minus in between. So I'm going to get rid of this 4 by dividing both sides by 4. Divide this side by -4 actually, and divide this side by -4. This way, this -4 cancels out with that -4, leaving you with tangent theta equals -1. Okay, now here we have to use our unit circle. We want to look for a place where tangent of theta equals -1 in the unit circle, because we want to find this value of theta. And here's the thing, remember that tangent, a little note on the side here, a little note, that tangent is of anything, well, tangent of theta is equals to sine of theta over cosine of theta. Okay, and whenever this thing is equals to, let's say, 1 or something like that, well, let's say 1, it just means that this sine and this cosine have to be the same value at a specific point. The most common value, it's going to be like the root 2 over 2 over root 2 over 2. That would give you 1. In this case, we don't have 1, we have -1. Okay, that means that these two have to be the same, but at least one of them has to be negative. Okay, one of them has to be positive, the other one has to be negative. So I'm going to go and look at my unit circle. Here is my unit circle, and I'm going to be looking for places where both sine and cosine are the same. Look over here, root 2 over 2 and root 2 over 2. This would be great if the answer was 1, but it's -1. So we want to look for something like this, but that we have a negative and a positive. Here we have that negative root 2 over 2 over root 2 and root 2 over 2. This works perfect. If I divide these two, I get -1. Check this one, they're both negative, so this would give us a +1. This one as well, positive and a negative. So my two solutions will be this one at 7 pi over 4 and this one at 3 pi over 4. So these are my two solutions. Let me write them down back on my notebook. So the solutions for theta are, we said 3 pi over 4 and 7 pi over 4. Alright, so these are our two solutions. This would be the answer, and that's it. Now you will follow the same process for problem number 5. It's the same thing. Okay, now I had another question on how to do other problems. There were problems 11 and 12, so let me take a look at them. So here are problems 11 and 12, and I'm looking at the best example that I can do to kind of show you how to do problems 11 and 12 is by doing problem 13. So I'm going to do problem 13. you're gonna see the process, the whole thing looks pretty complicated, but once you start working on it and once you know like all the steps to take, this will be like very simple. Okay, so let's take a look. Let's go back to the notebook and start writing problem 13 down. Okay, so problem 13 is -1 equals -2 plus 2 sine of theta plus 3 pi over 2. Okay, so this is the problem. Let's start working on it. Again, the first thing to do here is to take a look at the sign and try to leave this by itself. But now notice that, like on the first problem, we don't have, well, in this problem we just had a tangent of theta, pretty simple. Now in this one we have sine of this whole thing. Okay, so we pretty much want to leave this whole thing by itself. Okay, that whole thing we want to leave it by itself. So my first thing to do, it's pretty much to start by taking the -2 and add it to the other side. Plus 2 on both sides. Okay, I'm gonna rewrite everything. I'm just gonna put this side, this whole thing on the left side, and that is 2 sine of theta plus 3 pi over 2. Okay, I just rewrote this, and that is equals to, because we took this 2 to the other side, -1 plus 2, that's just +1. Okay, I want to get rid of that 2, so I'm going to divide both sides by 2. So this 2 and this 2 cancel out, leaving me with sine of theta plus 3 pi over 2 to be equals to 1/2. Okay, I'm pretty much done here with this part. I'm going to go to my unit circle and I'm going to look for the values where sine of whatever, where sine is it's 1/2. Okay, look the values where sine is 1/2. Okay, the places where sine is 1/2. Now remember that sine is my y value. Okay, sine is my y, so I'm looking for 1/2 to be on the as the second value. Okay, 1/2. There I have 1/2. Let's look for another 1/2 on the y value. I have 1/2 here, but this is on the x value. That would be cosine. So I'm looking for sine. So far I only have this one. 1/2. There's another 1/2. So we have this is 1/2 and this is also 1/2. Positive. Nice. This is 1/2, but it's negative. I don't want a negative. It's positive. And this also 1/2, but it's negative. So my only two values would be this one at pi over 6 and this one at 5 pi over 6, because these are the only two places where my y value is positive 1/2. Okay, so I'm gonna write down those solutions on my paper, pi over 6 and 5 pi over 6. Okay, so pretty much I'm gonna write them in green. Okay, just to point them out a little bit. I have pi over 6 and 5 pi over 6. Okay, so these are the places where sine is 1/2, but be careful, okay, because we're saying that sine at pi over 6 is 1/2. Okay, that's what this solution means. That sine at pi over 6, it's 1/2. Same thing with the other one, sine at 5 pi over 6. This is also 1/2. Okay, but here's the thing. We want to find the specific value for this. Okay, so we have to take this whole thing that's inside of the parentheses, this let me write it up here, no, on the side, theta plus 3 pi over 2. Okay, so this thing has to be pi over 6. Has to be pi over 6. Okay, I want to find the value of theta, so that when added to this gives me pi over 6. So to do this, I'm going to subtract both sides, 3 pi over 2, and subtract 3 pi over 2. I'm going to multiply top and bottom by 3. So I get this to be pi over 6 minus 3 pi, oh wait, 3 times 3, that would be 9 pi over 6. So I get this to be negative 8 pi over 6, which simplifies to, because they're even values, negative 4 pi over 3. Okay, that was a little bit long, but this is for this solution, the pi over 6 solution. We have to do something similar to the 5 pi over 6. So I'm going to do it down here. So we're going to have theta plus 3 pi over 2, but now equals to 5 pi over 6. Same process, leave the theta by itself. Let's solve for theta. So I'm going to subtract both sides, 3 pi over 2. Subtract 3 pi over 2 minus 3 pi over 2. I'm going to multiply again, top and bottom by 3, so that I get 5 pi over 6 minus the 3 times 3, that's 9 pi, and over 6. Okay, let me continue down here. This gives me 5 pi and negative 9 pi, that's negative 4 pi over 6. Okay, and I can simplify this a little more down to be equals, because it's even, negative 2 pi over 3. Okay, so far we have two solutions of theta. Theta is equal to this, and theta is also equals to this. These are my values of theta, and we would think that that's it. But we're not there yet, because, give me 1 second, we're not done yet, because remember that our parameters are from 0 to 2 pi. We cannot go above 2 pi, and we cannot go below 0. If we look at these values for theta, they are right. These are the right values. If you put these into the calculator, sine of negative 4 pi over 3, that would give you 1/2. If you put sine of negative 2 pi over 3, that will also give you negative 1/2. The thing is that these are not between the interval 0 and 2 pi. So to make these values into being that interval, in that positive interval, I'm going to look for these values in the unit circle, and I'm going to actually put them in these unit circles. Okay, so first let's look for 4 pi over 3. Okay, positive 4 pi over 3. I know it's negative. Let's look for positive 4 pi over 3 on the original. 4 pi over 3. Look for 4 pi over 3. There is 4 pi over 3. It's towards the right from the middle on the bottom left. 4 pi over 3. So here's my original unit circle, and 4 pi over 3 was here. Let me change it to blue. 4 pi over 3. Okay, so in my original unit circle, 4 pi over 3, it's just right next to 3 pi over 2. So there's 3 pi over 2, and there's 4 pi over 3. So I'm going to do the same thing with the other point, which was negative 2 pi over 3. So here, 2 pi over 3, positive 2 pi over 3, it's up here, 2 pi over 3, right next to pi over 2. So 2 pi over 3, it's going to be here, 2 pi over 3. All right. This problem actually came out to be really easy. So here's the thing. Here's how this thing works. The values, these are the answers. This is the place where they are as if they were positive. Now, when these values are negative, the unit circle actually runs backwards. So this is the original positive unit circle. It goes from 0 to pi over 4 to pi over 2 to this value to this one, and so on and so forth this way. In the negative unit circle, the values switch. So instead of going like this one from here counterclockwise, then the negative unit circle, you go clockwise. So pi over 4, it's down here instead of up here. Pi over 2, it's down here instead of up here. But these values are negative. So pretty much you're taking, let's say, this value, and you are switching it up if you were to go to the positive. So again, let's take this negative value. Let's say we wanted to make it positive. It would be down here. So we want to find these values where they are located in the negative interval. So I would pretty much take this one and put it down here, and take this one and put it up here. They just switch places. So in the negative unit circle, negative 4 pi over 3, it's located up here, and negative 2 pi over 3, it's located down there. Now these are the points where my solutions are located in the negative unit circle. Okay, so the values that we got, these values, they are located here and here in the negative unit circle. We want those values but from the positive unit circle. Okay, so a value was up here and down here, which in the positive unit circle, it's up here and down here. So my values, my final answers are pretty much it's pretty much this and this, which are on the positive unit circle. So my final answer for this is positive 2 pi over 3 and positive 4 pi over 3. That's my solution for problem number 13, which is that. Okay, so my answers again are 2 pi over 3, comma 4 pi over 3. Okay, so your job might be to check specifically. We were lucky just that in this case, the two solutions on the negative unit circle are technically the same solutions in the positive unit circle. That's why our values changed. But let's say that we had a solution of only one solution to be negative pi over 4. Okay, let's say that we did a problem and we got negative pi over 4, but we were again working between 0 less than theta less than 2 pi. Okay, so forcing us to only use the positive interval. And we got this as the only answer, which in the negative unit circle, negative pi over 4, it's found here. To make it into the positive, remember that this, to make it into the positive, just switches upwards here. So in the positive unit circle, it's just here. what am I saying? In the negative unit circle, the answer is, it's pretty much this, where they would be reflected, okay? So this will translate to be this answer, 7 pi over 4. 7 pi over 4 would be the final answer. If this was this, our answer would be here on the positive unit circle. That would be the final answer.